Hello and welcome to State of the Project Meros. I am your ever handsome host, Cryptosi. I am joined by the man himself, Kayaba. In case you missed these podcasts, which have been going for the last few years, every single month, we come and we discuss all of the development happenings and things going on with a brand new cryptocurrency project, which is built from scratch, called Meros. Or Meros, as I used to call it, and was promptly corrected by Kayaba on numerous occasions. So what we do before I've realised that a lot of other YouTubers and podcast people say like and subscribe at this point in the video, so this is what I'm going to start doing. So before we go any further, I'll make sure you like and subscribe. Help spread the word, helps spread our mission, I guess, which is to build an amazing project and to get more and more people involved and keeping the transparency going. So what we're going to do is we're going to discuss various things such as Schnoor signatures and epochs or epochs. I know I'm going to get corrected on that pronunciation as well.
It was epochs.
Epochs, okay. And other such things. So without any further to do, let me introduce my ever-present guest, Kayaba. Kayaba, how are you, sir?
Doing okay. Recently my dog got a bit sick, so I've been trying to take care of that. But good otherwise. Just excited to get back to Meros. Took a few days off, unfortunately, but it is how it is.
Yeah, these things do happen. And I guess when you've been working on something for I guess you're past 3 years now. Are you past the 3-year stage now?
Yes, we are. That happened a couple of months ago.
Yeah, once you've been working on something for that long, I guess it's only natural that you have a few days off here or there. I've been working on something for the past few weeks, and I took 6 of those days off. Well, the past week, 6 of the last week. So let's start with GitHub. I was just checking through GitHub, and I noticed that you've made an entire new branch. Now, this suggests to me that you've got some serious heavy lifting to do, as it tends that when you do have heavy lifting, you do put it into a branch all of its own. And that is for the epoch, and not the epoch, the Epoch Redo. You've mentioned this a few times in past podcasts, but just for clarification and summation, what are epochs and why are you redoing them?
Sure, and sorry for looking to the side there a bit. I was just saying hi to my dog. I think I might have woken him up, so he's just walking over. So basically, transactions on Meros, they have to finalize. People vote on them. If they get enough votes, they're treated as confirmed and we move on. That said, we still do have a finalization process. So years later, we don't have all transactions being voted on in a redundant system. So because of that, we define finalization. And the rule is that transactions, despite being confirmed by votes, is still finalized by the blockchain. And the reason we have this rule, because it kind of sounds like we're defaulting back to the blockchain, and we are for a bit, is that if you get 51% of the votes, that means you have 51% of the hash power voting on a transaction, confirming it, meaning the blockchain is always going to follow the votes. And even if votes and hash power desyncs, because Meros, just quick summary, you mine a block, you get a token called merit. This merit token is what's used to vote. And when you vote with it, that's you putting your former hash power behind a transaction. But this lasts for a year. So you can mine a block, it's mined, great. And then you can vote for a year, and now you're no longer contributing hash power. So to kind of make up for this, people with merit also vote on blocks. They confirm them via a process called checkpointing, which is the next major feature I'm working on. So because the people with merit are voting on blocks as well, it's a very convoluted system. Sorry if I'm not doing the best to explain it. But the point is that transactions finalize on the blockchain. The reason we still call this instant feeless is because they finalize via votes, and votes are definitely going to be on the blockchain, because if votes are excluded from the blockchain, the people who voted on transactions won't vote in the blocks. If they don't vote in the blocks aren't accepted. It's a very intricate process.
Yeah.
And happy to answer questions. We do have the time. But the point was, with transactions finalizing, they finalize over a 6-block window by default. And that means that a transaction is mentioned on the blockchain, great, that's 1 block. And 5 more blocks happen, and then it's finalized. And after it's finalized, we just don't allow archiving votes anymore. So when it comes to archiving these votes, there's one important consideration, and that's when a double spend happens. If two transactions conflict, we need to decide definitively which one is correct and which one is wrong. When we're trying to definitively decide this, we need them to finalize at the same point in time, because if one finalizes as confirmed, the other one definitely can't be confirmed, so it needs to finalize as non-confirmed. So this gets tricky. So we have block number one, and block number one contains a standard transaction, and it looks perfectly fine. But then block number two comes in, and it's wait, nope, I also spend something from that. I also do that. Now we have a double spend. Block number one and block number two are spending the same inputs. This is a problem. In order to resolve this, the old system had them finalize at the earliest point in time. So instead of, I may be off by one here, but transaction one was going to finalize on block 6, and if transaction 2 wasn't double spend, it would have finalized on block 7. Under the old system, they were both brought back to block number 1, or block number 6. They would both finalize on block number 6. And this was called I think I called it the pushback system, in that if a new competing transaction popped up, it was pushed back to the older transactions. I don't really have a good term for it. I mean, epoch, that's the term. It was pushed back to the older transactions epoch. So let me try to take a ground up approach from this, because I know I'm not doing the best at explaining this. When a block happens, we generate an epoch. An epoch has a list of newly seen transactions. And it just says, after 5 blocks, we finalize the epoch, that's that. If a vote comes in a newer block, it's added to its relevant epoch. If a double spend happens, we don't put the transaction into the new epoch. Instead, we put it into the old epoch. I think that sums it up well enough. How am I doing so far, Cryptosi?
Yeah, that does make sense. That does actually make sense to me.
So, honestly, I forget a lot of the intricacies of the system, because I designed it originally years ago. I noted the problems years ago. I did the write-ups years ago, and it's only just now I'm putting it back together. But there was some issue with this. And I know the very simple answer of why it's an issue, but the simple answer is dismissible. But basically, at some point in time, I decided the pushback system was a problem. And I have an immediate answer for why I think it was a problem, but I don't actually remember if it was the right answer. And I'm running it through my head, the chance that I'm thinking of the right thing. So basically, at some point in time, for whatever reason, and I'll try to get back to you on this, I decided that the pushback system was flawed. And instead, what we should do is bring it up. And there is an obvious advantage. I'm trying to remember why it's important, but the obvious advantage is that if a transaction appears on the blockchain, it at least has those 5 blocks assigned to it. So now, instead of saying, if we have a transaction in block 1, it finalizes in block 6. If we have a competing transaction in block 2, it also finalizes in block 6. One has 5 blocks to finalize, one only has 4 blocks. So under this new system, it brings it up. Transaction 1 is brought up to block 2, and both finalize in block 7. And because of this, both of them have 5 blocks to be voted on, talked about, and so on and so on. And the immediate answer for why this is good is it stops ramming through transactions. If you publish a transaction on block 1, you just have it sit there. You don't add any more votes for it. And then when the time comes, on block 6, you create a block with the double spending transaction, and you're like, here's a slightly more amount of votes, and it just goes through because it's right there and there's no time to discuss it. I feel like there was more of this, and it irks me. I don't have perfect recall right now. But if I recall correctly, that was the reason for changing, is just so you can't ram through transactions. You can't mine a block with a transaction, don't get any votes on it, but trigger finalization because of that, and then later add a competing transaction and have it give it slightly more votes and ram it through on that premise. Now, if you try to define a transaction late, it brings both up, so both have a full period to be voted on and discussed. That said, we also have checkpoints, and checkpoints would also stop this exact problem, because checkpoints would say this block is missing verifications, and it's a whole thing. I think I just tackled this problem from 2 different angles. So there is this ram through attack, and it's my biggest concern. And that, say you get the majority of hashing power, you define a transaction with a minimal amount of votes, yet you still get to double spend it because you don't archive votes for the actual winning transaction. It's like Cryptosi, if you create a transaction and then 10 minutes later try to cheat it, the one from 10 minutes earlier is almost certainly the right transaction. I mean, technically it's not that simple, but practically, yes, it's the first transaction. That's the correct one. If a miner only gives it one vote, or since you're pulling off this attack, if you only give it one vote on the blockchain and then later give transaction 2 votes, that is still a microscopic amount of votes. One has 1 vote, one has 2 votes. Yet you would still ram it through because of just the hash power behind it. So we actually have 2 solutions for this. One, when you define a competing transaction, it re-extends the epoch. It changes the epoch and ensures that there's multiple blocks ahead of it. And then 2, there's the checkpoint system. So I think it's just a multi-pronged solution to a problem where, yes, miners would decide the chain, because that's definitely what we don't want to do. When miners decide the chain, you're stuck to the latency of the blockchain. So when we have 10-minute blocks, it's just not a solvable problem in a good way.
What does spring to mind when you talk about that is the time that has elapsed since you've done the first epochs and since you've now come and decided to redo it. During that time, anyone that's been following these podcasts has watched your development as a developer. So I guess you're seeing that the issue with new eyes, because you've got new options and you know more. Do you wonder that maybe in another 3 years' time, you may come back and look at a lot of the things that you've done now and decide, you know what, I could probably redo those better as well? And if that's the case, how do you decide when enough is enough? So, for example, for this Epoch Redo, is it a case that you feel that it's a legitimate attack vector or more of a optimization? And at what point do you say, okay, enough is enough, now we're going to go with what I've built now as opposed to what I can build in 10 years' time, if you get my drift?
I do actually think it's a legitimate security issue, and that's one of the main reasons I want to fix it. But one of the things I've definitely thought about is how sane is the protocol? How easy is it to implement? What are the oddities of it? How do we make sure it's sane? How do we make sure it's complete? How do we make sure it's comprehensive? And we're going to talk about this in a bit later, because I know you brought up in our topic Schnoor signatures, and this also applies. And then last episode, I believe we talked about partial merit removals.
Yeah.
And that's another example of this. Partial merit removals don't make sense. It's one element that's theoretically, it's something that's already known to the network, and then it's a new piece of data and saying, hey, these 2 pieces of data conflict, these 2 votes conflict, so on and so on, with the assumption that one is already known to the entire network and one is new. If one is already known to the entire network, you don't need to send it around. Sorry about my hair, by the way.
Okay.
So
sorry about
because
mine.
of that, so right. So it's just really, we should not have to deal with this. We shouldn't save this to the network now because it's stupid. It's simple to remove, so on and so on. And that is just an optimization, but it's quick and easy enough and effective enough. I believe it should be done now. And yes, there always is going to be discussion about this, but I think the fact that I'm not yet adding sharding or proof of stake is kind of showing I do have a line here. While I think epochs is not only important to the sanity of the protocol, but also security, I do think it's something we should do now, especially due to how frustrating it would be to implement later, because then we would have 2 different finalization systems running at once.
Okay. Awesome. Beautiful segue into our next question, which is Schnoor signatures on Meros. Now, I'm pretty sure I've done a butcherous job of researching this because it kind of did confuse me. Now, there was a issue, or I guess a feature request, to add Schnoor signatures to Meros, which is a mouthful. Now, I wanted to ask you, what are the pros and the cons of this? And I get this confused, I know I do, but do we not already have BLS signatures? And are the 2 not competing technologies?
So they are. So Schnoor signatures.
It is a mouthful.
They're just another signature format. So I don't want to define a signature format like in the podcast. I don't think that would be beneficial. But they're just another signature format. They're a way to sign data. And they have very interesting properties, which I appreciate. But the main thing I appreciate about them is their simplicity. They're some of the simplest signatures around. And that's why I want to implement them into Meros, because it would be easy to do. It'd probably take me an hour or two, but it would be a very simple, it would be a great simplification. And it's where the future is heading. So it's just something that we might as well do it now, because doing it in the future isn't that helpful. As for BLS, that's been in the code base for years. And one of the things touted about Schnoor is its properties for multi-signatures and aggregation. And that's where BLS also takes a shine. So with BLS, the ability is that anyone can take one signature and just add them together. So Cryptosi, say you sign something that says, I like tea. You're a Brit, you like tea. Says you sign a signature for that. And then say I sign a signature saying I prefer soda. Great. So we now have two signatures and they both take up 96 bytes of data. The thing is that now any individual party can take those signatures and they can create a joint signature, which is also 96 bytes. But to verify the signature, it's both Cryptosi likes tea, Kayaba prefers soda. And so it's a single 96 bytes representing both of them. And the reason we use that is for votes. When you vote on something, you vote for a transaction, and Meros allows you to aggregate that. So anyone on the network can say, here's a vote for transaction X, here's another vote for transaction X. Now here's a single vote with both parties, yet a single signature. In using this, every 10 minutes and every block, we create a single signature for every single vote that happens for that block. And it's a major space-saving optimization. With Schnoor signatures, and we don't need Schnoor to do this, but it's very nice with Schnoor. One of the things we could do is have, instead of anyone creating these signatures, we can have the voters in real time craft these signatures per vote. And the advantage of voters doing this in real time, instead of miners doing it whenever they produce a block, but voters actually doing this in advance, is it would be much faster. BLS is very slow. It's not slow enough, it's unusable. There's a reason a lot of protocols, including us, are using it, but I fully acknowledge it's slow, especially compared to something like Schnoor. So with Schnoor, voters would do it ahead of time, and they would produce a single signature, which is actually a bit smaller at only 64 bytes. And this 64 bytes would represent every vote for the transaction. And it would be much faster, and I appreciate that. That said, there's two problems with this. First of all, if you do it on a per transaction basis, which is the only way that makes sense, you can't have a block with one signature for every transaction votes. You need to have a block with one signature per transaction. So in the long run, the space of it is a bit worse. But that said, you get much better speed in the moment, because in the moment, you're not dealing with one BLS signature for the entire block. You're dealing with one BLS signature per transaction. Because in the moment, you're receiving transactions in real time, and you're receiving votes in real time, and so on. So it's much faster. It's slightly smaller, but it doesn't have the same aggregation properties, and it's full of trade-offs. But the other problem with it is the network complexity. When you actually want to create votes in such a manner, when it's interactive instead of non-interactive. The distinction here is, like I said, anyone can take the statement, Cryptosi likes tea, Kayaba prefers soda. Anyone can create a joint signature of that. So when a miner who's been listening to the network the entire time goes to create a block, they can just create the signature. They don't have to say, hey, can I get everyone to participate in this? But with Schnoor, they have to go, hey, Cryptosi, you wanted to say you like tea. Great, good for you. But Kayaba also wants to say he prefers soda. Can I get the two of you to work together and send each other a few emails to produce a single signature for me? Great, thanks. And it actually is this messaging protocol. I think the current protocol uses at best 2 rounds, but the better protocol uses 3 rounds. So if we wanted to produce a joint signature, Cryptosi, we would have to agree in advance. We have to say, Cryptosi, we're both committing to our favorite drinks. Let's go, Cryptosi. And I would have to send you an email. You'd have to send me an email. I'd have to send you an email. You'd have to send me an email. I'd have to send you one. You'd have to send me one. And then we get our signature. With BLS, it's just, hey, Cryptosi, what drink do you like? Yeah. Oh, great. You like that. Great. Thanks. Hey, Kayaba, what drink do you like? Great. Thanks. Oh, I can add these together. And it's much simpler as a developer. And this actually goes to what you were saying about trade-offs. Because if you ask me in a perfect system where you have perfect time to develop whatever you want, which one would I prefer? If I would prefer Schnoor multi-signatures, in this case called Musig, or if I would prefer BLS for voting, I would probably pick Musig in a perfect environment. Because while I appreciate BLS, I think the speed is going to become a problem in the long run. And that's my honest take on it. And I think there's a lot of interesting research into it, especially with hardware acceleration. And I think it would be very interesting if people were buying USB keys to run Bitcoin nodes, to run whatever, Ethereum 2.0, Meros, whatever. I think that would be a very interesting thing, because you could easily design a small, like USB size of a flash drive that had the hardware to do cryptographic ops for all these nodes on a level way faster than your standard CPU. I also don't think that's practical. So I think CPUs are going to shape up and implement hardware that helps out with this sort of stuff. But until they do, that's the problem. And if you ask me perfectly, yes, I'd probably pick Musig as my personal favorite. It would just take so many developer resources to implement, and we don't have them. And BLS is still great, and it's a trade-off. And I can't definitively say Musig would be better anyways.
We did speak about, I think it was with Spock. We spoke about BLS.
Real quick.
Yeah.
I just want to say, so these two systems are going to work together. Standard transactions are going to use Schnoor signatures. So transaction signatures aren't aggregated. They're just standard elliptic signatures. And the reason for this is the speed of them. As I said, they're fast. And when you're only doing one signature per transaction, it's not really an issue. But when it comes to votes, where there's a lot of votes, say you have 30 people voting, right now you have 30 signatures, that starts to take up a lot of space. So transactions, we're less concerned about space because it's only one signature per transaction. So that uses Schnoor signatures in this case. Whereas votes, where we have a lot more of them, to presumably 10 to 30 to, I don't think we'll get 100 voters that are actually impacting the network. I do think we're looking at the tens, which isn't as decentralized as I was like, but it's a start. But when we're looking at 10 to 20 to 30 people, yes, that would be a problem if we had 30 signatures per transaction. And that's why that part uses BLS.
So the two coexist then? It's not one or the other?
Yes.
Like, okay. Mm-hmm. Okay, excellent.
Yep.
When you say 10 voters, is that the equivalent of 10 nodes as us mortals would?
It's 10 miners who are running nodes and actively validating transactions.
Okay.
It doesn't have to be active miners. It can be historical miners as well. Merit, the token we vote with, lasts for an entire year.
Yes, of course. Okay, brilliant. Now that tidies that up. So it's mm-hmm. quite a good optimization then, which makes sense. It's only going to take you an hour of your time, and it doesn't take out BLS. I want to talk about one of the Epoch commits. I should really have followed it on with the first question, but it was in the Epoch's branch, actually, to be fair. Mm-hmm. And the reason why I wanted to ask it is because I know it's probably not that interesting of an answer, but it did seem like an odd commit to me, to my novice eyes. And it was get Meros to compile. Now, what's the meaning behind as a commit? What's actually going on there?
I pushed code which didn't compile because I just was getting my thoughts out, and I had some code, and fixing it was going to take another 30 minutes, hour, but I felt it was important. It made enough changes. It was important enough to get its own commit. So I committed it, and then it didn't compile, because the expectations for Meros is that the master branch, the main branch, always compiles. If you go to GitHub, you download a copy of the code, the default branch will always compile. When we work on other branches, though, they are not guaranteed to compile. They are not guaranteed to work. They are not guaranteed to pass the protocol specification. It's the Wild West. So because of that, I felt the work I had done was good enough to warrant a commit, but I still had to clean it up. And I could have done it there, but I rather have created the commit with my thoughts as is, because when you're doing edits, it's important to... I was happy with my thoughts as they were. I was completely happy with them. They didn't compile. That part I wasn't happy with. But my point is that I knew I didn't want to go back and delete my code, erase it, undo it. And because of that, that's why I created a commit. A commit is saying, I am ready to say this work is good. This work should be committed, so on and so on. And I felt the work had achieved a scope where it was starting to become unmanageable. And I felt the work it presented was clear enough on its own, even if it didn't technically compile. So I kind of wanted to cement it before I had a risk of messing it up, because you can see your changes from the last commit. So I could see every change I made. Great. I was happy with those. That's why I signed off on it and pushed it off. But at the same time, if I continued editing, yeah. So it just gave me a reference point. And if I undid a feature, because there's a difference between a feature and a bug. Like, it's kind of bad terminology to use here. But my point is that I was happy with my thoughts. Let's call them features. It does X, it does Y, so on and so on. I was happy with all of that. But when I was fixing the bugs that didn't let it compile, I didn't want to accidentally undo what I had meant to write when thinking I was solely fixing a compiler bug. So by committing it then, it allowed me to compare to just that, and that gave me a good view of it.
I kind of interpret this as GitHub is like being able to look under the bonnet, and going into these branches is like being able to go to the factory, because I guess we're getting to see things with like ultra transparency. So you're getting to see things before they're even completed, when they're still effectively swirling around in your mind and just immediately been put into the computer. I think it's super interesting. I'm really glad I asked that question now. So thank you for that answer. More transparency as per usual. The next one is also from the Epoch's branch, as everything was this month. I'm assuming it was the thing you was working on this month, the portion of Meros.
Yeah.
This particular, I think it was a commit. Yeah. I just loved the wording in it, and obviously it completely went over my head. It was add support for datas which have magic inputs to Epoch. Magic input. How can you not love that? So
we have three different actions.
What is a magic input? And why would you want to add support for these magic inputs?
So we have data transactions, and they let you store small segments of arbitrary data on Meros. They have magic inputs. So when you create a data, you just create a data. And the first data, it always has some input. And in this case, it's the zero hash. The zero hash is literally 32 zeros. And that says this is the very first data. It comes from nothing. It's brand new. It's the start of a chain, so on and so on. And when we create this data, it's great. You have a hash of 0000. Now the Epoch says, wait, I'm looking for competitors. Do any of you compete? Wait, two datas? They both have a hash of 0000? You guys must not be friendly. But the thing is that the zero hash is what we call a magic input. It's not an actual hash. It's 0 bytes of data to signify it's brand new, it's dark, there's nothing before it. So because of that, it's a magic input. It's a hash which doesn't actually exist, but we're still claiming it does. And data transactions are actually something I want to redo, but probably won't before mainnet just due to time considerations, which we can talk about later or another time if you want. So that's a magic input, and I just had to code the epochs to say, hey, these transactions are allowed to compete. You know, if you see two transactions with a zero hash, they don't actually compete. They're still friends. They're just different. But it gets a lot more complicated than that, because if you tell the epochs to ignore it, then it's not ever going to say, hey, we need to finalize this data, because it ignored it. So I had to code support for accepting the zero hash's existence, but not tracking it as a competitor.
Very, very, very interesting. Very interesting. Okay. So effectively, that's what a magic input is, and it can only ever be 0000000. It's always going to be.
There is one other magic input in the code base, which is the genesis hash. Every block creates a data to ensure there's always something to vote on, because if merit holders don't vote, they actually have their merit locked, which can be problematic for the network if everyone has their merit locked. So to ensure there's always something to vote on, every block creates a data, and the block the data the block creates has the genesis blocks as its input hash.
Okay. Bug fixes. I guess I've got a link to it, but it was just literally another commit where I guess you were just going over bugs.
That's probably very similar to compiling Meros.
Yes.
It's just I wrote code. It probably compiled if I didn't write get to compile. It probably compiled. It just didn't work as expected. So bug fixes is just getting it to work as I wanted it to work.
Yep. Okay, so we've rifled through my questions for this month a lot quicker than usual. So you can labor on these answers to these questions that I seem to ask you each and every single month. But if I don't ask you, I'm telling you right now, the millions and millions of comments that we will get and emails that I'll get, people will probably be posting me letters saying, why haven't you pushed this man? When will we be seeing the next testnet, Kayaba?
So that's going to be when Meros is theoretically ready to launch. I have epochs to finish up, which I'm hoping to finish up within the next week. And then the other feature I have is checkpoints, which is how we also stop the ramming through blocks and so on. It's by actually voting on the blocks. So if someone does rent enough hash power to 51% of the chain, they still can't do whatever they want with it, which would be very problematic. After those two features, there's theoretically the MDF, which has a very troubled status as of right now. But after those two features is when I feel like...
I'm going to have to pause. There's somebody at my front door. Hold on 1 second.
All right.
What were we talking about? Bug fixes.
You asked when testnet.
When testnet.
And I said the MDF has a troubled status.
Right. Okay. So from that point, so explain to me the MDF's troubled status.
Explain to you about the MDF's troubled status. I don't like it. I think it's good in theory. I think I created what would be the best DAO out there, especially compared to the Bitcoin ones. I think it's clunky. I think it was obviously tacked onto the protocol. I still don't think it's good. So there's things about it I appreciate. Still don't like it.
I love the MDF.
Yes, and it's something we very much disagree about, but when it would also take me an extra month or two to program in, there's also the time consideration. So when I'm not as of yet happy with the protocol, and I really would be looking more towards off-chain mechanisms comparable to the Monero CCS when it comes to practicality and ability and timeline.
So have you got a date in mind for the testnet?
If this feature takes another week, checkpoints are expected to take 2 to 4 weeks, and then it's missed bug fixes. So hopefully 7 to 8 weeks, which is shorter than 3 months for once.
Yes. The eternal 3 months are finally coming to an end.
Now it's the eternal 2 months, isn't it?
Yeah. No. Well, let's not jinx it. How long are you planning on running the testnet for? So effectively, when will the mainnet then launch?
It will run for a month, and if there are no issues, then the mainnet will launch.
Yeah. If there are issues, we'll go in, or you will go in, and you will fix those issues, I assume. Yep. Okay. Well, Kayaba, we have completed our podcast this month a lot quicker than usual. Got some very concise answers to some very interesting.
Well, you're welcome to ask more.
Well, the thing is, I think because we're only working on epochs this month, it's. I don't want to bog people down with epoch overload. Let me think. Was there anything else I wanted to ask you about involved? Oh, I'll tell you what we still haven't, what we didn't ever get to the bottom of. There was a time when you needed a Java developer, I'm going to say.
Nope.
No, what was the developer? Python, that was it. Did you ever get around to finding said Python developer, or is it still a position that you're looking for?
That is still something I'm actively looking for, and I plan to put out a few more leads over the next few days on that.
Okay, so that's another thing that we can shout out whilst we're killing time here, just chewing the fat, padding out our podcast. Yeah, so if there are any Python developers out there, please get in touch. If you are interested in Meros, please join our Discord. It's where all the cool guys hang out, and gals, obviously. And yes, Kayaba, thank you very much for your transparency, especially the extra transparency with the items which are being posted to GitHub before they can even compile, because I love that. I think that's great. And thanks very much for all your hard work. Really enjoying watching this project come together. And I shall speak to you next month, sir.
Sounds good. Thank you as always. Happy to be here.
Excellent. Thank you.